This video is about z-scores. First of all, the definition for a z-score. It represents the number of standard deviations away from the mean We use z-scores to standardize studies so that we can compare two different studies to each other. There is a formula, of course, for z-scores. Z equals the value x minus its mean divided by its standard deviation, or if we're using the population symbols, the z-score would be the value x minus the population mean divided by the population standard deviation. Some characteristics to remember is that the z-score is positive when it is above the mean, and the z-score is negative when it is below the mean. The z-score is equal to 0 when it is at the mean. Also, the z-score does not have units. It is just a numerical value. So let's look at some examples. If we wanted to find a z-score and we knew the mean of a newborn baby's was 7 pounds and the standard deviation was 0.8, what is the z-score of a 9-pound baby? So we're using the formula z equals 9 minus 7 divided by 0.8, which gives us 2 divided by 0.8, which is 2.5. So the z-score is 2.5. Another example, we had, we're looking at the heights of male adults. And we have the mean to be 70. And we have the standard deviation to be 4 inches. What is the z-score of 78 inches? So again, we would use that formula, z equals 78 minus 70 divided by 4. So we have 8 divided by 4, which is 2. So the z-score is 2. Very, very easy formula to use if you have your information handy. So we had the mean of 70, standard deviation of 4. We're finding the z-score for 78. So 78 minus the mean divided by the standard deviation gives us 8 divided by 4, which is 2. I didn't have that last example there where you could see it all the way through. So just wanted to be sure you saw that. All right, our next example. We have a problem where we have the mean to be 178.2, a standard deviation of 40.7, and a value to be 239.15, and we want to find the z-score. Using that information, we would have 239.15 minus 178.2 divided by 40.7. That gives us 61.05 divided by 40.7, or 1.5 for the z-score. So that's 3 examples using just the formula straight up. Now let's look at a comparison problem. We have Rita, who makes an 80 on her history test. Her class has a mean of 60 and a standard deviation of 25.5. We have Joe, who made an 80 on his geometry test. His class average was a 70, and the standard deviation was 14.5. And we want to decide who had the best score. Well, since they both scored 80, it's kind of hard to say. So we're going to use z-scores to compare who had the best score. So we're going to look at Rita first. The 80 minus the 60 divided by the 25.5 gives us 0.78. And then Joe, who had 80 minus 70 divided by 14.5 gives us 0.69. Since Rita's z-score is higher, we can say that Rita scored the best. So that's how we can use z-scores to help compare two different kinds of problems to determine how they compare to each other. And just another little note is to remember that z-scores that are positive are above the mean, and z-scores that are negative are below the mean. So sometimes when you're computing these, you are going to end up with negative answers sometimes when you're finding z-scores. Now, in our next video, we're going to be finding z-scores using a table of values. And in your directions, I've given you a handout that you either needed to print or you need to have access to. So you need that for the next video that we're going to be working with.